Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're gonna talk about the NSX-T 3.0 integration with Kubernetes. So this is the last CNCF survey from the last year, where Kubernetes users talk about their experience with Kubernetes and also what they think that are the biggest challenge to use that solution. In this case, we have here the first one is like culture change. So the way that we deploy Kubernetes is a little bit different than using other platforms to develop. And also they have some challenge with security, complexity, and monitoring network. And from like the 6 major issues here, we can use NSX to address 4 of them. That's security, complexity, monitoring, and training. And this session, we're going to cover these 4 challenges here and also see how we can use Kubernetes in this integration. So Kubernetes use something called Container Network Interface, or simple CNI. And this allows that some vendors like VMware develop a third-party plugin to integrate with Kubernetes and deliver network. And NSX use this integration behind as the integration with NSX will be done by a component called NCP. That's the NSX container plugin. So in the left side we have Kubernetes, and in the right side we have NSX. And to do this integration, we're going to have here in the middle the NCP. NCP will talk API with Kubernetes and talk API with NSX. NCP is some containers that run. And the Kubernetes cluster will have some containers, some pods actually, that run in the master, and also others that run in the workers. And they will exchange, like they will translate the Kubernetes language to the NSX language. Basically, is what NCP does. So in Kubernetes, we have namespace. And when NCP figures out that there is a new namespace in Kubernetes, it will tell NSX that a new namespace was created, and automatically NSX will create a segment to host that namespace, and also all the routing that's needed using a T1 gateway. And if it's a netted network, it will create also the net rules. We also have the pods that will be hosted in that namespace and will be connected to a network, to a segment. So NSX will create a container interface and will connect that container interface to that segment, providing also the IP address to that pod and everything that's needed to communicate. Here in Kubernetes, we can deploy security rules, like we can enforce our security posture using a network policy. In NSX, we're gonna control that using the distributed firewall. Here we have 2 ways of doing that. We can deploy the network policy using the Kubernetes CLI, and also we can create the distributed firewall rules in NSX that will be applied to the pods that are running in Kubernetes. So both ways are fine and work well. Also, we have the Ingress for load balance, for L7 load balance. This way, when you create an Ingress here, everything that's needed for that to Ingress work the rewrite rules, and also the load balancing rules to the pods, to the pool, and also the inclusion of that pool and that pods in a pool. All of things will be done automatically in NSX. Also, the service, like if you do like a service, layer 4 load balancing, we also can use the NSX for that, providing L4 load balancing for the pods. So to start this integration, we have Kubernetes that will deploy the pods and NSX that will deploy the connectivity. So this way, NSX will be integrated to Kubernetes using a YAML file, and for everything that's created, it will deploy the firewall rules, the networking, the L2 networking, the L3 networking. Here we can have routed networking and also netted networking. We can also have the load balancing rules here and apply tags to everything. The way that tags work here allow us to create firewall rules based in tags based, and also load balance rules tag based. So when you tag a pod, when you tag like an application, automatically we include that pod or that application in a load balancing or in a firewall rule. So NSX will provide routing, switching, load balance, either L4 or L7, and distributed firewall, and also visibility. Visibility is something really nice that you can check like the connectivity from like a container pod or a pod port to a database VM, and check the communication between them. If you have like a firewall rule that's blocking the communication, or if the communication is working fine. So to start, we're going to create a namespace. The namespace will be created as kub control, create namespace vBrownBag. This namespace will be created, and also the source net rule. So here we're gonna create kub create namespace vBrownBag, and here you can check the namespace was created, and also the, let me just zoom here a little bit, and also the logical suite that will host the containers to that namespace. So the next step is to create an application. So our application will be called vBrownBag Replication Controller. We have here two sets of replication controller. One is the web, and the other one is the app. So when you create that, we will create two pods of each one of the replica sets, the replication controllers. We're going to apply the configuration, and we're going to check here the container creation. After a few seconds, everything is created, and you can check here that they are also connected to my segment. We can check here all the four pods connected to that network, and everything looks fine till now. The next step is to create a service and an ingress. So the service will group like the similar pods in the same group, like in the same service. The same service will be shared for like the similar pods, and you're gonna do that using labels. And also we're gonna, in this case, we're gonna have a service called web and another one called app. And also we're gonna create a Ingress rule to load balance the external traffic to either web or app based in the URI. So everything that's /web will be load balanced to the web service, and everything that's /app will be balanced to the app service. And also we have here our VIP that's will be the external IP for that application. So we're gonna take a look in our service YAML file. So we can check here that we have two services, the web and the app. And based in the labels, we're gonna do the load balance. So here, apply the configuration for service. You can check the service and now the ingress. So I'm gonna take a look in the ingress configuration, and here we can see that we have /web to the vBrownBag web and /app to vBrownBag app. I'm gonna apply this configuration to our namespace vBrownBag, kubectl get ingress, and here you can see that our URL vBrownBag.demo.corp.local is running. Here we can check the rules that match our regex for load balance. Here's the /app, and here you can take a look in the /web. Also the rewrite rule to /, and we can check if it's successful working, accessing our URL. I'm using here a private certificate, and everything's working fine for web. Now let's take a look on app, and everything looks fine also. The next and last step for this demo is the microsegmentation. So based in the labels, we're gonna provide the security for the environment. So we're gonna take a look in our configuration file, in the Replication Controller YAML file, and then we can see that all the labels have also been applied to the pods. And here, based on those labels, our distributed file will enforce the security posture that will block the communication between web and app. We're gonna take a look in the Replication Controller configuration YAML file, and you can check here that we have two labels, vBrownBag web and vBrownBag app. Now we're gonna check where those pods are running. So we're gonna SSH to Kubernetes worker 1, and now take a look on the pods running there. And we're gonna enter in the second pod, and to do that, we're gonna start bash inside that container, and once inside that container, we're gonna start to try to communicate with other pods in the same network. So I'll start the communication with like a web container, then to the same web container, and then to app. And I can see here that the communication from web to app is working. Here I'm going to create another group called vBrownBag Web. And this group will use labels, tags, as will be tag based. So it automatically discovers what was created in Kubernetes. So here I have the web vBrownBag. This will be our source, and our destiny will be the vBrownBag app. We also will create a dynamic rule to include everything, all pods that has the tag app in the scope vBrownBag. Once configured that, we will set the reject and publish this rule. Now I'm going to do the same test, and you can check that the communication between web and app doesn't work, while the web to app is still working. So this concludes this presentation. Thank you very much for watching, and see you next time.